Hello, this is Mr. Huber. In this lesson, we're going to learn about factoring trinomials. First, let's multiply two binomials together. That'll lead us into this a little bit. So we can do this by distributing the x into the parentheses and get x squared plus 3x. Then we can distribute the 4 into the parentheses, and we get 4x plus 12. And we know if we simplify that, because we have two like terms in the middle there that can be combined, we'll get x squared plus 7x plus 12. Right? Now if we look at this, factoring means we want to go back from here to find out what were the factors that got us this trinomial. Right? We're trying to figure out what multiplied together to get us this. So in order to do that, right, to factor that, we can see a pattern here where the 3 and the 4 multiplied together and gave us a 12, and they added together in the middle and gave us a 7. So to factor the trinomial, where there's a 1 in front of the x squared, that's our a value will be 1. So ax squared plus bx plus c, that's standard form for a trinomial. The a, the b, and the c are some numeric constants, coefficients, and a constant at the end. Okay, we want to multiply to get the c value and add up to the b value. So in this case, what multiplies to give us 12, the c value, and adds up to the b value? The only combination that would do that would be 4 and 3. So we could find our factors would be x plus 4 and x plus 3, because 4 and 3 are the correct numbers that multiply to give us 12 and add up to 7. So let's see what that looks like with some other examples. Again, if we're going to factor this, we want to multiply to get c and add up to the b value. So in number 1 here, what multiplies to give us 10 and adds up to 7? Right? So when we're doing this, we also want to pay attention to the signs. We're multiplying to get a positive 10, and we're going to add to a positive 7. So if we multiply to get a positive number, they both have to be the same sign. They're either both going to be plus or both going to be minus. Well, I can't add two negatives and get a positive, so I know that I'm going to have a positive and a positive. So I need the numbers that multiply to give me 10 and add up to 7. That'd be 5 and 2. We're going to talk about checking with swings. Okay, I call it checking with swings, so you make little swings in the middle here. We can see if the middle term's working out correctly. 5 times y is 5y, and 2 times y is 2y. When I add those together, I get 7y. That middle term matches with this middle term. That's a good sign that I worked it out correctly and got the right term there in the middle. Okay? So pay attention to the signs on your binomials, on the b and c values, so you're factoring these correctly. In number 2 here, we're going to have n and n. And again, they're both going to be positive. And I want numbers that multiply to 24 and add up to 11. So it'd be 8 and 3. Okay? You might have to come up with a list. So 24, that's 1 and 24, 2 and 12, 3 and 8, 4 and 6. Maybe write them out, and then you can see, okay, which of those adds up to the correct term in the middle there. And we could check with swings as well. Or you could multiply the whole polynomial together. Right? If I want to see if this works, I could distribute the n into the parentheses and get n squared plus 3n. And I could distribute the 8 into the parentheses and get plus 8n plus 24. Okay? And if I add those two terms in the middle together, I get n squared plus 11n plus 24. And I know that it was the right middle term, so I know this factoring is the ones that work. All right? So now if we look at number 3 here, we have m squared plus 3m minus 4. So I want to factor this. One of the first things I need to do is pay attention to the signs. I'm going to have m and m. Now to multiply and get negative 4, I'm going to need a positive number and a negative number. Right? I mean a positive number and a negative number. Okay? Which means when I add them together, I'm really subtracting to get 3. So that's 4 and 1. Okay? I want to subtract because I'm adding 4 plus negative 1. Adding a negative, that's like subtracting when they're different signs. Okay, so when they're different signs, think of it as adding a negative is subtracting to get that b value. So these are the factors that would multiply to give me negative 4 and add to give me positive 3. All right. And then in number 4 here, I'd have x, not n, so I'd have x and x. And I want to multiply to get negative 12, but add to get negative 8. So they're both going to have to be negative numbers. To multiply and give me positive 12, they have to be the same sign, but I'm going to add two negatives to get negative 8. That's going to be 6 and 2. And keep in mind on this, you could have x minus 2 and x minus 6. It's fine. Doesn't matter which binomial is first or second. Okay? Or in this last one, right, if this was the minus 1 and this is the plus 4, that's fine. Well, you can't have a minus 4 and the plus 1, though. Okay? But you could have the m minus 1 as your first binomial and the m plus 4 as your second binomial, and that's fine, because you're multiplying, it'll give you the same thing when you distribute. All right, so now let's look at number 5. W squared minus 5w minus 6. All right, so when I factor this, I'm going to have w, and I'm going to have a positive and a negative. This is a common one because you think, oh, 3 and 2. 3 times 2 gives me 6. So I'd have W, let's say plus 3, and W minus 2. Okay, that gives me negative 6. But when I add these, if I checked with swings, I'd have 3W minus 2W, and I add those, I'd get 1W. That's not the right middle term. That wouldn't work. Okay, so I'd know that doesn't work. Right? They have to be different signs, and they have to add to negative 5. That's going to be 1 and 6. Okay, positive 1 and negative 6. Those multiply to give me negative 6 and add to give me negative 5. And then number 6 here. So I've got two variables. That's fine. I got an x and a y. That's fine. In my second term of my binomial, I'm going to have a y then. So I'm going to have positive and a negative because I need to multiply and get negative 20. And I want to add up to a positive 1. Keep in mind, right, there's a 1 there that I don't have to write, that we don't see in front of that x, y. So it's going to be a positive 5 and a minus 4. Right? So those are the numbers that multiply to give me negative 20 and add up to positive 1. All right, before we see some more factoring, what athlete's given birth name is Cassius Marcellus Clay? Cassius Clay was more popularly and commonly known as Muhammad Ali, considered the greatest, one of the great heavyweights of all time, one of the great athletes of all time. Muhammad Ali was Cassius Clay before he changed his name. All right, let's get back to some factoring. Number 8, n squared minus 11n minus 60. So again, I want to find out the factors of negative 60 that add up to negative 11. I know I'm going to have one positive and one negative factor because I want to multiply to get negative 60. And so sometimes it might be helpful. Like on 60, there's a lot of factors. So I might want to write out my list of factors. So a 1 times 60, 2 times 30, 3 times 20, right? 4 times 15, 6 times 10. And I've got a whole list of factors there now, and I could run through those and figure out which ones, one positive and one negative, are going to add up to negative 11. So in essence, which ones are going to subtract and give me 11. I could see right here, right, 4 and 15, and I want to have negative 11, so I want to have the 15 be the negative and the 4 be the positive, because I want to add them and get negative 11. 4 plus negative 15 would give me negative 11. And on any of these problems, if you want to see if it's the right factoring, multiply them back together. Okay, let's multiply these back together. I could distribute the n into the parentheses. I'd get n squared minus 15n. And then I could distribute the 4 into the parentheses. I'd get plus 4n and minus 60. And when I combine my two middle terms, I'd have n squared minus 11n minus 60. Hey, what do you know? That's the same as what I started with. So I'd know that my factoring is correct. Right? So if you want to find out if it's the right factors, distribute, multiply back together, and see if it gives you the right polynomial that you wanted, the trinomial that you started with. And number 9 here, we're going to factor this x squared plus 9xy plus 14y. So again, we have two variables, that's fine. We're going to have an x, and we'll have a y on our second term, and we'll have an x, and we'll have a y. And it's plus 14, so they're going to be the same sign, and they're both going to be positive, because I'm going to add up to a positive 9. So I need factors of 14 that add up to 9. It'd be 7 and 2. Again, you could put the 2y and then the 7y, that's fine. So x plus 7y, x plus 2y. That would be my factored form for that trinomial. So what numbers multiply to c, add up to b. If there's that second variable, include that in your factored form. And again, check it by multiplying them back together and seeing if it gives you the polynomial you wanted. That's an easy way to check and see if you're on the right track with your factors that you come up with for any of these problems. Now let's see how we can solve some equations. When we have an x squared here and an x, right, and then we have this 50 over here, we want to get this equation so that it equals 0 on one side. Then we can use factoring. We've learned about the zero product property. So I want to subtract 50 on both sides. All right? So I'm going to have x squared plus 5x minus 50 equals 0. And now I can factor that. So I want to factor the left side of this equation. That's going to be x plus 10, x minus 5 equals 0. Right? Those are the factoring, the numbers that multiply to give me negative 50, add up to positive 5, and I want to set each factor equal to 0. So I'm going to take each factor equal to 0, and then solve the resulting equations. So I'm going to subtract 10 on both sides to get x equals negative 10, add 5 to both sides, and get x equals 5. Those will be my two solutions, negative 10 and 5. All right, in the next example, so I'm going to get it set equal to 0 by subtracting 15m on both sides. That's going to be m squared minus 15m plus 36 equals 0. And now I'm going to factor it, so I'm going to have m and m. They're both going to be negative because I need them to be the same sign and add up to negative 15, and I'd have 12 and 3. So I can set each of those equal to 0. M minus 12 equals 0. M minus 3 equals 0. And I can solve those by adding 12 to both sides. Give me m equals 12. Add 3 to both sides. M equals 3. And I got my two solutions. M equals 12 and m equals 3. If you'll recall, finding zeros is the same as solutions, right? Roots, zeros, solutions, those mean the same thing. So in this situation, find the zeros. That means find the values of the variable that will make the equation equal to 0. Well, equal to 0. That's where I can use the factoring and the zero product property to solve this. So first I'm going to factor this to what numbers multiply to give me 18 and add up to 11, both positive, so it's going to be 9 and 2, positive 9 and positive 2. That equals 0. So I have 0 equals x plus 9, 0 equals x plus 2. Then I can subtract 9 on both sides and get negative 9 equals x. I can subtract 2 on both sides and get negative 2 equals x. So my solutions would be negative 9 and negative 2. For this next one, number 13, I can find the zeros, and I have it equal to 0. So negative x squared. So we're going to have to deal with that negative sign. So we'll do something a little different here to handle that negative sign. So we don't want to have a negative in front of that x squared. So I'm going to divide everything by negative 1. Okay? Because if I divide 0 by negative 1, it's still 0. And on the right side, it's going to change the signs of all the terms. Okay? But now I've got a positive 1 x squared. So my a value is a positive 1, which is good. So now I can factor this. And I want numbers that multiply to give me negative 120. So it means I'm going to have a positive and a negative. And they have to add to negative 2. So it's going to be a positive 10 and a negative 12. And then when I set those each equal to 0, and I subtract 10 on both sides, I get negative 10 equals x. And I set the other factor equal to 0, right? All factors equal to 0. And I'm going to get 12, equals x. So that's x equals negative 10 and x equals 12. Write that a little more clearly there. So 12 and negative 10 are my two solutions. You could plug them back in too. Check them back in, plug them back in the original equation, make sure they make the equation equal to 0, right? And the other problems you're solving, plug them back in, make sure they make the original equation true, and you know you have the right proper solutions. This next one, find the dimensions of a rectangle with an area of 96 feet squared. So a rectangle's length times width. So that's going to be x times x plus 4. That's going to equal 96. So that's an equation I can work with. When I distribute that x into the parentheses, I'm going to get an equation that looks like the ones I was solving before, where now I need to get it set equal to 0. So I can subtract 96 on both sides. I get x squared plus 4x minus 96 equals 0. And now I need to factor it. So I'm going to factor, and I need numbers that multiply to give me negative 96. So that's a positive and a negative number. And they have to add up to 4. So you could try, okay, maybe on your calculator, oh, what's 96 divided by 2, divided by 4, divided by 6? I'd try mostly even numbers because 96 is an even number. But you want to try different factors. You want to find the ones that then will subtract and give you 4. So that's going to be 12 and 8. Okay, those are the proper factors. I can set each factor then equal to 0. X plus 12 equals 0. X minus 8 equals 0. When I subtract 12 on both sides, I get x equals negative 12. I add 8 to both sides, I get x equals 8. And one thing you want to do here, when you're solving a problem, check it. In this case especially, you want to check and see, do these actually work for the rectangle? Negative 12 won't work and give me a side length that's negative. That's not possible. I can't have a side length that's negative 12 centimeters or inches or something. So no negative lengths. So negative 12 actually won't work for this problem, but the 8 will. And my dimensions, the dimensions of the rectangle are, plug the 8 back in here, it's going to be 8 and 8 plus 4 is 12. So my dimensions are 8 and 12. That's the length and the width of that rectangle. We can use factoring. Again, when we're factoring, find the numbers that multiply to give me C, add up to B, pay attention to those signs, check by multiplying the binomials together, check by using the checking with swings at least a little bit to see if that middle term's working, and make sure you're paying attention to, do those factors, are they the ones that would give me that original trinomial that I was trying to solve in that